Assalamualaikum class. Today we'll be going into chapter 5, which will be on sound. Now, before we start, the question I want to ask you is, why do you think people use the sound in their multimedia project? Okay, I do not know why, but every single time I ask this question to my students, what they would say is, well, because it's attractive. No, don't you dare say that. Why do people use sound in their project? Because it's attractive. Why do people use image in their project? Because it's attractive. Why do people use text in their project? Because it's attractive. The word attractive can be very, very general. Okay, so the only elements that you can use the word attractive is for graphics, because in our previous video, you know that graphic deals with the aesthetic of the project, what we see, the thing that attracts us. That is graphics. But for sound, it is not about being attractive. Okay? Why people use the sound in their multimedia project? This is because we want to invoke some sort of emotion. For example, okay, let's take a movie, for example. Okay, have you seen a movie where they don't use sound? Do you think without sound you'll be able to cry instantly? Without sound, would you feel scared when watching a horror movie? Think about it. Okay, if you watch a movie, let's say a horror movie, okay, and then you don't have that you know, that really suspense song, do you think you'll feel scared? I don't think so. Because sound, it intensifies and heightens your mood or your feeling. For example, like sad movie, like the scene is sad, like you feel like crying, but as soon as the sad song comes on, that's when your eyes just start bawling out. You get what I mean? So people use sound to sort of heighten their emotion, to basically gives an impact to the project when it comes to the users or the audience's emotions and feelings. Okay, so basically, how do humans hear sound? Okay, humans hear sound through sound waves that travel into our ear canal until it reaches the eardrum. So whenever we have sound, okay, sound is actually a sound wave that travels into our ear. The thing that allows us to hear is due to the eardrum. Okay, since the sound travels and it vibrates into our eardrum, it will hit our eardrum. Okay, imagine our eardrums like, you know, the regular drums that you play. It'll hit the drum, which causes the fluid inside our ear to reach our brain. Okay, that is how we hear and perceive sound. Okay, so whenever it hits our brain, it'll affect on our emotions and things like that. So it is how our brain perceives the sound. Some people like a very mellow song. Some people like rock songs. Okay, it depends on how our brain interprets the sound. But in general, sound is just a sound wave that will travel into our eardrum. Okay, and it will hit it, which causes the signal to sort of, starts within our brain. Get what I mean? Okay. So how is sound created? Sound can be heard by our ear due to the sound waves that were created. Sound waves basically are the vibrations that travel through the air caused by a vibrating object. When things are silent, nothing is moving. But if I clap my hand, what happens is that this is an object. This object is vibrating, which causes the particles in the air to vibrate and travels into our ear. Okay? The vibrating object will radiate sound waves outward in all directions. So when I clap my hand, the particles, the vibrations that travels from this particular object will travel in all directions. So the people that is in front of me, on my side, in the back can hear me because it travels in all directions. Okay. So when an object vibrates, it causes the air particles around it to move. So although we can't see the particles around it, but the particles are moving. Okay, so the particles will bump into particles that are close to them, and this continues until they run out of energy. So if I clap my hand, okay, when will the sound stop? The sound will stop when the energy has depleted. Okay, so for example, if I clap my hand in my ears, okay, the particles will travel into my ears until there is no more energy. So when there's no more energy, I can't hear the sound no more. All right. So let us try this. Okay, I want all of you to try this. Okay, put your finger, any finger, and just put it on your neck. And I want you to say "ah" as loud as you can. For example, ah. What can you hear? You can hear the sound, but at the same time, you can feel the vibrations in your throat, right? Because sound is basically a vibration. So if you say it loud, ah, and you say it, now say it as soft as you can. Ah, ah. So what happens is that when you say the ah sound really loud, you can really feel the vibration. But if you say it really, really softly, you can hardly feel the vibration. Now, why is that? Because sound is an energy. The louder your sound, the more energy that it gives. The softer your sound, the less energy that it gives. That's why when you do ah, you can't really feel the vibrations in your throat. Okay? So basically, acoustics is the branch of physics that studies sound. Right? Okay, so we talk about sound. There are two main things that we need to look at, which are amplitude and also frequency. Okay, every single sound that is created will have these two properties. So the first one will be amplitude. Amplitude refers to the energy of the sound wave. It is the size of the vibration. In the previous example that I gave you, where you put your finger onto your throat, right? The loudness of the sound will refer to the amplitude. Okay, so amplitude is actually the size of the vibration, or the size of the sound wave. The louder your sound, the bigger your sound wave would be, and the higher the energy of your sound. Okay, so for example, if I talk really loud, okay, imagine someone with a really loud voice. Can the people at the back hear them? Yes. Let's say you are in a classroom and giving you a lecture and have really loud voice. Can the people at the back hear me? Yes. Why is that? Because there is higher energy. When there is higher energy, the longer your particles can move across the room. Okay, that's why it can reach the audience at the back. But if my voice is very soft, okay, if my voice is very soft, the energy is less. When the energy is less, it can't travel further to the back. So only the people at the front could hear me. You get what I mean? Okay, so amplitude refers to the energy. So the higher the energy, the higher the volume, which is the size of the vibration. Okay, now amplitude refers to, or it is measured in decibels. Okay, low amplitude, lower energy. High amplitude, higher energy. Okay, just remember that. So the next property would be frequency. Frequency refers to the speed of the vibration. It is actually the pitch. So whenever I produce a sound, there's a difference between volume and also pitch. This is volume when I speak loudly. Okay. This is pitch. You know, people who have a higher pitch, their sound is very high. So this is also a pitch where I have a lower pitch. Now, if you have a girl's voice and a guy's voice, a girl's voice will have a higher pitch than the guy's voice. You get what I mean? Okay. So a higher pitch will cause the vibration to have a higher speed. For example, okay, if I compare you a person with a higher pitched voice, imagine Doraemon. okay, and a person with a lower pitch voice, right? If I put you to the people who have a high pitched voice and a low pitched voice, which person do you think will cause you to have like really hurt eardrums? Like, oh my gosh, please get that person away from me because it hurts your ears. Of course, the people with a higher pitch. Why? Because when you have a higher pitch, the vibration, the speed of the vibration is very fast. So it hits your ears very quickly. So that's why you feel that your eardrum hurts when people with Doraemon voices talking to you. Do you hear me? Okay. Whereas the people, okay, I don't know if you noticed this, but if you have a guy who have a really low voice and you try to talk to them, you can't really hear what they say. Why is that? Because when their pitch is low, their speed is low as well. So in order for you to really hear what they say, they have to increase the volume, kinda. Okay, because the speed is slow, it kind of it slowly reaches your ears, so you're like, what, you know? But if they talk low, but with a higher volume, then with a higher energy, it'll get to your eardrum. You get what I mean? Okay, so pitch will be measured in hertz. Okay, so the two differences are amplitude and frequency. Amplitude is the energy, whereas frequency is the speed of the vibration. Okay, there is a clear difference between the two. Alright, so when it comes to audio recordings, there are two basic types, which are analog and also digital. Okay, analog refers to sounds that are recorded using things like vinyl records and cassette tapes, where the data are not stored in digital form. Okay, so we talk about digital audio, the data will be in terms of bits. Okay, so our computer, our phones, all of the sounds that are recorded inside those devices will be in bits, which will be in digital form. Okay, so things like, you know, sounds in cassette tapes, okay, that is analog audio. How it is recorded, it will be recorded onto that magnetic tapes. Okay, so when we record that sound, it will actually replicate the original sound wave. So the original sound wave will look exactly the same as the analog sound wave. Whereas a digital audio, how we record it is totally different because it is in bits. Okay, how the sound is recorded, the sound will be taken using samples. Okay, so the original sound will be recorded in terms of samples at a specified rate. Okay, so that is how digital audio can be recorded. Alright, so if you take a look here, the original sound wave and the digital sound wave looks a little bit different because the digital sound wave will be in terms of bits. Okay, so digital audio is actually known as sampled sound. Why we call it sampled sound? Because the sound, when we record it in digital form, we will record it or take it in terms of samples. All right, so the process of creating the sound in terms of bits is called digitizing, where the sound wave will be represented, of course, in terms of bits. All right, so when we digitize the sound or making the sound into a digital audio, okay, there are two main steps, which are sampling and quantization. All right. Now, so let's take a look at the first process of digitizing, which be sampling. So it says here the recording of digital audio is not done continuously. Instead, it's done in steps at regular time frames. At each time interval, the amplitude of the original sound wave are recorded. This is known as sampling. Now, let me put it in simpler terms. When you record a sound, okay, imagine that, let's say you take your phone and you click on the record button. All right, when you click on the record button on your screen, you know, as you record the sound, you will notice that the sound is actually recording at the same time as you're speaking. Okay, since you're doing it in real time and you're trying to record what you're hearing, the device will actually take samples of that sound. Okay, so when it takes samples, this is quite similar to when you want to take a picture. When you take a picture, you're taking the light that you see, right? Okay, so similar to how sound is, when you're talking, it is taking the amplitude as we speak. That's why when you record the sound, you will notice that there are waves forming. Okay, so this is known as sample. Within that certain time frame, okay, as you're speaking, within that time, they will take that sample and record the amplitude of the sound. That is how the sound waves are recorded. Okay, so basically sampling will break up the sound wave into intervals along the time axis to produce a sequence of signals. That's why when we record a sound, okay, along the, once you have finished recording, we notice that, let's say you have a 10 seconds recording, okay, you will notice that along that 10 seconds of recording, you have 1 second, 2 seconds, 3 seconds, 4, 5 seconds. Every single second will have their sound wave forming. Okay, this is known as samples. All right, within a certain amount of time, the samples are taken in order to replicate the original sound wave. Okay, so sampling rate is the number of samples taken per second. Now, when we record a sound, we can actually specify the number of sampling rate. The higher the number of samples that we take per second, the more the higher the resolution of the sound will be, because there will be more data that we can record. Okay, so the sampling rate is measured in hertz. Alright, so now let's take a look at the quality of a digital recording. Okay, when we talk about the quality of a certain audio, it will actually depend on these two things, which are sampling rate and sampling size. Now, if I give you these two different sounds, a sound with a higher resolution and a sound with a lower resolution, okay, the sound with a higher resolution will have a better quality audio, whereas a lower resolution will have a lower quality audio. Why is that? When you have a higher quality audio, it means that the sampling rate would be higher and the sampling size could also be higher. Okay, how does it work? How does the quality of the sound refers to the sampling rate and the sampling size? Let's take a look at the first one, which would be the sampling rate. Sampling rate refers to the number of samples taken per second. This is measured in kilohertz. For example, let's say I have a sound that is recorded with a higher sampling rate and have a sound that's recorded in a lower sampling rate. Okay, let's say the higher sampling rate is 44.1 kilohertz. And this one is 20.1 kilohertz, for example. Okay, the one with a higher sampling rate, okay, imagine as if, okay, it's kind of similar to a picture. Okay, let's say you want to take a fast moving person. Let's say you want to take someone skateboarding. Okay, as you know, when someone is skateboarding, they will move very fast. So when you have your camera, okay, and you want to take that shot, the moving shot, okay, you will click it very, 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 very fast, right? In order for you to get every single movement. Now, imagine the shot where you take the, with a camera, you take a lot of shots very quickly, and another situation where you take the shot and you click on the camera very minimally, okay? Which one would have a smoother images? Okay, there's a smoother movement of the images. Of course, the one that you click very, very fast, because we are able to record every single moment of the action. Okay, when you take the the picture very slowly, okay, there are moments that you can't capture. So that's the difference between a higher resolution and lower resolution. Now, this refers to the sampling rate as well. So for example, when we record an audio, okay, and you imagine you are taking that recording as we speak multiple times, a lot of times, very fast, okay? So every single moment, every single sound that is recorded will be more in comparison to the audio that we take less samples, okay? So you can't take as much data as to the one with a higher sample. You get me? Okay? So if you take a look here, okay, a lower sample rate will take fewer snapshots of the sound wave, whereas a faster sampling rate or a higher sampling rate will take more snapshots of the audio. Okay, so that's the difference between the two. So, for example, okay, a digital audio that has a sampling rate of 44.1 kHz has 44,100 of samples taken per second. Within that 1 second, imagine there are 44,100 of samples in order to create your audio. So if you have a lower sampling rate, then per second there are less samples recorded for that particular sample. That's why you have a lower resolution. Okay. So another thing that affects the quality would be the sampling size. So the sampling size refers to the number of bits or the bit depth used to describe the sample. Now, this is also similar to, I don't know if you remember the bitmap, okay? Like I said, in a bitmap image, we have pixels, right? Inside each pixels, it will determine the number of colors that can be displayed on the screen, okay? The higher the number of bit depth, the more colors that we can display on the screen. This is similar to the sound as well. The higher the bit depth of the sound, the more amplitude or the more volume that we can record or describe the sound. Okay, so if you take a look at these two images right here, a low bit depth, you can't really record that much amplitude. So there isn't that much difference in between each sampled sound. Whereas if you take a look at the next image, okay, it has a higher bit depth, meaning that there can be more variations of the amplitude that is taken. All right. So for example, a 16-bit digital audio will have 65,536 of volume values to choose from for every sample that is taken. So if you have a lower sampling size or lower bit depth of the audio, okay, let's say an 8-bit digital audio, of course there will be less volume to choose from in order to create that sound. Okay, so like I said, the quality of your sound will depend on the sampling rate, which is the number of sample, and the sampling size, which is the number of bits in order to record our sound. Okay, so the next process in digitizing the sound, once we have recorded our sample, okay, the next process that we need to go into is called quantization. All right, once the analog audio has been acquired from sampling, which is our first process, it needs to be converted into a sequence of digital values in bits. Okay, like I said, a digital sound will be recorded in bits, which in digital form. Okay, in order for us to get our sound into bits, we need to go into a process called quantization. So how it works is that quantization will take the value of each sample and round it off to the nearest integer. The sample's amplitude will be rounded to the nearest predetermined value. So as we all know, okay, bits or digital data will be in terms of zeros or ones. So the values that we have in our sampled sound will be rounded off to the nearest predetermined value, either 0 or 1. Okay, that's why the sound, instead of looking like that, it will either be 0 or 1. Okay, so that will be in terms of a digital form. Okay, when we have go into quantization, okay, the process of quantization, sometimes when we trying to convert into bits, there are certain things that could happen to our audio. Okay, maybe unwanted background hissing noise can occur, or clipping can also happen as well. So how it works is that, let's say that unintentionally when we record our sound, there could be some background hissing noise when there are a little bit of error going on inside that. You can hear some sound inside our audio. That could happen. This is caused when we're trying to convert that into digital form. I mean, it's not your fault, just sometimes, not all the time, sometimes rarely, there could be error in quantization happen, okay? Or clipping can occur. For example, let's say when we have an audio that is very high pitched, okay? So when we are trying to convert that into digital form, clipping can occur. How clipping works is that when the audio is too higher up, okay, somehow the top of your amplitude or the sound of your sound wave, it kind of gets clipped. So the sound is somehow distorted, okay? So, I mean, this kind of thing could happen when we go into a process called quantization, okay? All right, making digital audios. There are two ways of making our digital audio file. First of all, we could make it from scratch, right? By recording our sound through a microphone. So when you have a microphone or an external mic that is not built into your device, okay, let's have an external mic, all you need to do is just plug it into your microphone jack and then you can just start to record your audio, all right? Another way is for us to digitize an analog audio. Let's say you have a cassette tape, okay, and you wanna take the sound from that cassette and convert it into a digital format like MP3. What you can do is you can use some sort of a hardware. You take the hardware, so and you plug it into a computer, so it will somehow transform the sound in analog form into a digital form, okay, which you can then edit your sound in your devices and things like that. All right. So when you prepare a digital audio file, please keep in mind, okay, of balancing your need between sound quality and file size. What I mean by this, okay, a higher quality will produce a larger file, a larger memory, okay? So when you have a lower quality, of course, it will be less memory size, all right? So if I ask you this question, do you prefer, okay, let's say you want to burn a CD of songs inside there. Do you prefer to have less songs but with very high quality, okay? Or you prefer to have more songs but with less quality? So depending on your need, you can balance out between file size and also the sound quality. That's what I mean by this, okay? If you prefer a higher quality, then you need to sacrifice the memory. But if you prefer to have less file size, but the quality of your audio will be sacrificed, okay? So another thing that you need to keep in mind when preparing your digital audio file, you need to set a proper recording levels to get a good clean recording. What I mean by this is that when you record your sound, you will notice that in every recording software, you will notice that there is a volume levels or the decibel levels at the side of your software, okay? You will have green, yellow, and red, okay? The higher you go, the color of your bar will get to red. So when it gets to red, meaning that there could be distortion occurring inside your audio file. So imagine if I take my microphone and I put it really close to my mouth, okay? What happens is that it can cause some sort of distortion to the sound because the decibels of the image is not of a good proper recording level, okay? So your sound can be a little bit pecah, you know, your suara can be pecah, right? So you don't want that. So make sure that you set a very proper recording level so that you can have a very good, a clean recording without any distortion appearing in your audio. Alright, so let's go into editing your digital recording. So when you want to edit your audio, there are a few techniques that you can do. So the first one would be trimming. Okay, trimming means to remove dead air or blank space from the front of a recording and any unnecessary extra time off at the end of a recording. What I mean by this is that when we talk about the word trim, okay, trim, so if we go to a hairdresser, okay, and you ask the hairdresser to trim your hair, that hairdresser won't actually chop the whole entire hair, right? What it does, it will only take a tiny bit off the ends. So the same thing goes with audio recordings as well. When you want to trim the recording, it will somehow remove the, the extra things that you don't want at the front of the recording and the extra things that you don't want at the back of the recording. It will trim the edges off. So for example, when you record your audio, sometimes you say, okay, 1, 2, 3. Okay, Assalamualaikum. So the first part that you don't want, it is called trimming. You remove the extra newest things that you don't want, the unnecessary things. Okay, so that is trimming. So the next technique is called splicing. Right, splicing is removing the extra newest noises that inevitably creep into recording by cutting them. Let's say you have a recording and you try to record your audio, then suddenly your friend came into the room and say, hey. So within your recording, you will have this hey sound that you don't want. Okay, what you can do is can cut them out. Okay, if you want to cut them out, you will somehow splice it out. Okay, you take this part off, and you will remove that particular audio. Okay, so you will have these two different audios that are separated. Okay, but in order for you to combine them back together, this is called assembly, where you will paste together recordings into longer recordings. Okay, so you have splicing and assembly. All right. So another technique we have is volume adjustment. This is also known as normalization. This is by raising or lowering your volume level of each recording to provide a consistent volume level for the audio as a whole. Now, when you do any project that involves audio or video, okay, really listen closely to the audio that you put inside your project, because there are projects whereby the editor would just place the audio as it pleases without hearing the audio levels. Okay, imagine when you record a certain video and the sound of the video is very low. Okay, so when the video is the volume of the sound is very low, the audio will somehow turn up their volume level in order to hear your sound. Okay, but if the next sound inside your video is very loud, imagine, okay, the audience has the audio in a higher volume, right? And then suddenly when the next audio plays, you know what I mean? Okay, the eardrum will somehow, it will really hurt, because there is a clear difference between the audio levels. You have a low audio level, suddenly you have a spike of audio level. Okay, so the consistency of your audio level is not the same. So please do not do that. So when you do your video project or things like that, keep in mind of the audio level so that all of the audios will stay consistent. Okay, there's no too much difference between the audio levels. Okay. The next technique is format conversion. Okay, so this is by saving files in a choice of format to allow the recording to be played on a particular platform. So depending on your platform, you somehow need to convert your audio. So for example, if you want to play it in your MP3 player, then you might need to convert it in .mp3 file. Okay, so if you want to play it in another device, maybe you would need to convert it into another format. So this is known as format conversion. Okay, another technique we have is resampling or downsampling. This is by reducing the number of samples of the recording, which allows the recording to have a lower resolution. Okay, let's say you want to put a sound inside your project, but the project can't have very high, let's say the device that you want to play on doesn't have a very high memory. So what you want to do is you want to reduce the file size. When you reduce the file size, of course, the quality of your sound will be lower because there is less data stored. So since there are less data stored, the number of samples will be reduced. Okay, so this is known as resampling or downsampling. We are reducing the number of samples in order to lessen the data that are inside there. Okay, so when we compress an audio to save space, okay, we will actually do some resampling or downsampling to that audio, right? Another techniques that we have are fade ins and fade outs. Okay, this is to smooth out the very beginning and the very end of a sound file. So when we do a project, okay, any video project, okay, we can actually fade in the audio, meaning that the audio, instead of just play it, you know, as it is, okay, we can actually make it smoothly come into our project. So that is known as fade in. Fade out is when we slowly take the volume down and go out. Okay, so we can do that to our sound file. Alright, next we have is equalization. Okay, equalization is modifying the recording's frequency content so that it sounds brighter or darker. So we deal with the pitch of the sound. Okay, so let's say you want to make the sound of your file very happy, so you deal with a higher pitch. So you modify the frequency of the sound. All right. So that is equalization. So the next technique is called time stretching. Time stretching is when we alter the length in time of a sound file without changing its pitch. Okay, let's say you have a sound file of 5 seconds, okay, and you want to fill in, let's say there is still a tiny gap of another 2 to 3 seconds. Okay, what we can do is we can stretch the sound to fill up the time slot. Okay, what we do is we're stretching the time. Instead of from 5 seconds, we're stretching it to 8 seconds. So, but be careful when you stretch the time. Sometimes the pitch of the sound can be lowered because you are trying to make the sound a little bit longer. Okay, but time stretching, okay, we are altering the length in time without actually changing its pitch. Okay, try not to stretch the time without changing the pitch too much, right? Stretch your time properly. Okay, so another technique we have is digital signal processing. Okay, this is when we process a sound with special effects. For example, when we have a sound, we can place some effects on there. For example, let's say you place a hall effect. So when we place a hall effect to that sound, or a bathroom effect to that particular sound, probably there would be more echo to the sound. Okay, so you can produce some sort of special effects onto your sound. Alright, this is known as digital signal processing. Another technique we have is reversing sound. So this is reversing all or a portion of a digital audio recording. Let's say you want a particular part of your audio to be reversed. For example, if I say happy, then it could be I don't know. So basically that is how you can actually reverse your sound. So that is known as reversing the sound of your audio. Okay, now when we produce a digital audio, there are actually 2 kinds of digital audio that you need to know, which is a mono audio and also a stereo audio. Okay, when we record any particular sound, there are 2 types of sound that we can produce, which is recording it in monophonic or recording it in stereo. Okay, mono recording, it uses only a single channel, whereas stereo recording uses 2 channels. So what does it mean by these things? All right, a mono recording will produce the same copy of the audio signal, whereas stereo recording will produce 2 different audio signals. Now, let me give you a simple example. Let's say right now I want to record a mono recording. So since a mono recording only uses 1 single channel, I only need 1 microphone. Okay, let's say I want to record this lecture. So all I need to do is just place this microphone right down the middle. So all the sound that is produced within that room will be recorded onto this 1 single microphone. All right. So once you have finished recording, when you play it back, okay, let's say you put your headphone on, your earphone on. All right. Both of your left and right earphone will hear the same sound. That is a mono recording because both speaker, okay, both output will produce the same copy of the same audio signal. Okay, but if you record it in stereo, it uses 2 channels, meaning that I will have 2 different microphones. Let's say I put one on my right and I put another one on my left. Okay, so whatever sound that is nearer to that right microphone will be recorded there, whereas a sound that is nearer to the left microphone will be recorded here. Okay, so when you put your earphones on, you can actually hear two different sound produced inside our right and left earphones. Okay, I don't know if you've experienced this before, but if you play a certain songs, okay, and when you have an earphone that one of the earphone is broken, okay, if you have a mono recording, although one earphone is broken, you can still hear the sound and also the artist that is singing the song. Okay, but if you have an MP3 or a sound that is a stereo recording, if you have one earphone that is broken, okay, then suddenly you can't hear what the artist is singing. You can only hear the music. Okay, sometimes that can happen when you have a broken earphone and you use a stereo and you hear a stereo recording, because there are sound that is not being produced within this one speaker. You get me? Okay, because two of the sound are two different things. So it is more dynamic. You can hear more things within these two speakers, whereas with mono recording, both speakers will produce the same sound, right? Now, audio resolution, okay, will determine the accuracy of which the sound can be digitized. Like I said, the higher the resolution, the more bits will be stored as the sampling size, okay? So when you have a higher resolution of your sound, higher sampling rate and also higher bit depth, okay? So higher sampling rate, higher bit depth, higher quality, so the sound recorded will be more accurate to the sound that we hear, right? So audio resolution is measured in bits per sample. Within that one sample, how many bits are stored, right? So 8 bits is equals to 1 byte, right? So this is how we actually calculate the size of a digital recording, all right? So if you have a mono recording, the formula is sampling rate times the duration of recording times resolution times 1. Because with mono recording, there's only one type of sound produced. Whereas a stereo recording, the same formula, sampling rate times duration of recording times resolution, but you times it with 2. Because there will be 2 different audio channels, all right? So let's try to calculate the size of the following digital recordings. So I'll show you how. Okay, so let's now calculate the size of the following digital recordings. So the first question says, this recording is a 10-second mono recording at 22.05 kilohertz and 8-bit resolution. So the formula to calculate any digital recordings would be this one right here. Sampling rate times duration of recording times resolution times n. So the n will depend on whether the recording is a mono recording or a stereo recording. So let's take a look at the first one. So the formula for the first question would be sampling rate. So if you take a look at this question, the sampling rate is measured in hertz. So as we know, 22.05 is in hertz. So this is our first one, 22.05. Since this is in kilohertz and we want it in hertz, so what we need to do is we need to calculate it by, since it's a kilo is 1,000. Okay, so 1,000 times duration of recording, since this is a 10-second recording, so times 10. Okay, and then resolution, so the resolution is 8-bit. So this, what we want is an in byte. So 1 byte is 8-bit. So 8 divided by 8 times n. So n will depend on if it's a mono recording or stereo recording. Since it's a mono recording, that would be 1. So we can calculate that. Okay, 22.05 times 1,000 times 10 times 8 over 8 times 1. So let's try and calculate it. So it's 22.05 times 1,000, and that would be 22,050, and then times 10 times 8 over 8 is 1 times 1, so we would get 220500. So this is in bytes. So our answer for the first question is this one, for a mono recording, Okay, so the second question says a 10-second stereo recording at 44.1 kilohertz and a 16-bit resolution. So again, the sampling rate is in hertz, so we know it is 44.1 since it's in kilo, so times 1000. Okay, times is of course a 10 seconds, so times 10, and then since it's 16-bit resolution, so 16 over 8. Since this is a stereo recording, it would be times 2. So if you take our calculator out, so 44.1 times 1000, we would get 44,100 times 10 seconds, and then we times 16 over 8, so that would be 2. Okay, and then we times 2. So 1764000, 764000. So this is in bytes. Alright, so we have talked about digital audio. Now let's talk about MIDI audio. What exactly are MIDI audio? Okay, MIDI stands for Musical Instrument Digital Interface. There is a clear difference, digital audio and MIDI audio. Digital audio is a digitized sound, meaning that it is the sound that we hear and we record it. Okay, so when we record it, there will be sound wave. All right, so we record it in terms of sound wave. But with MIDI audio, it is not a digitized sound, meaning that there will be no audio waves. You can't see the wave of the sound. Okay, instead, what it contains, it will contain performance data, which is the set of instruction. Now, if you take a look here, okay, how do you know if it's a MIDI data? Okay, if you open up a MIDI file, it will not contain any audio wave. Instead, it will contain what buttons or what things that are pressed in order to produce that sound. For example, if we use a keyboard, okay, if we record a sound, let's say I record happy birthday on a keyboard, okay, a digital audio, okay, or a digitized sound, what we do is we take our phone, okay, and we click on the record button. So as we play the keyboard, the sound that we hear will be recorded into that device as sound wave. Okay, but with MIDI sound or MIDI audio, instead of recording what we hear, we are recording what button are pressed on the keyboard. For example, we click on F, then G, then A, then F and B at the same time. Okay, so it is not the sound that we hear. We're not recording what we hear, we are recording what we press. Okay, so the thing that we press will produce performance data. Okay, basically performance data are instructions on how we can produce that sound. Okay, so it will tell the computer how to generate that particular sound. Okay, firstly, in order to create this sound, we need to click on A, then F, then G, then C, blah blah blah. That is a MIDI audio. Alright, so basically a MIDI file, okay, is a list of time-stamped commands that are recordings of musical action. So when this is sent to a MIDI playback device, a sound is created. Okay, so we play the MIDI file on a MIDI playback device. Okay, the sound will be created depending on the performance data that was recorded. All right, so a MIDI file is device dependent, meaning that the quality of MIDI audio will depend on the user's MIDI device and playback device rather than the quality of the recording. So for example, if we record it onto our keyboard, okay, so we record this on a regular keyboard, okay, and then suddenly we play that MIDI sound onto a cheaper keyboard. Okay, let's say, you know, sometimes a electronic keyboard, a digital keyboard, we can play sound off of there, right? So if we take that MIDI file that was recorded on that keyboard, which has a richer sound, since it's more expensive, okay, and then we take a less expensive keyboard, okay, maybe the sound of A, okay, the key A in that keyboard sound a little bit different than the A key in that other keyboard. But we are pressing the same button, right, on this keyboard and this keyboard, but the sound will be different. Okay, so the sound of how the MIDI audio is produced will depend on the playback device, right? Now, to make a MIDI audio, okay, you need a notation software. So a notation software or sequencer software allows you to record and edit MIDI data. Okay, let's say you have our keyboard, okay, and what we do is we need to have a software, okay, we connect to our laptop or a computer, okay. So when we have that software, it allows us to record what are being pressed, okay. So then when we have recorded that, we can always edit using that software, okay. Sound synthesizer will convert that MIDI data into sound. So when we want to play that sound, the sound synthesizer will take whatever that is pressed and convert it into sound. Alright, a sound card will mimic the sound of instrument. Since a MIDI file is the performance data, right, what we press, so we can always change the sound or the type of sound that is produced, meaning that let's say we're recording it on our keyboard, but when we play it, we can play it in a trumpet sound, we can play it as a drum sound, we can play it as a xylophone sound, for example, because all that we do is just pressing. We press A, so an A on the keyboard will be different on the piano, or an A on a trumpet will be different, okay? But initially it is all musical data, okay? So when we have a MIDI audio, of course we need to have knowledge of music theory, because otherwise the sound will be gibberish. It's just us like pressing on different keys and stuff like that, okay? Now, MIDI file can also be edited easily by changing the MIDI composition, all right? So if you, every single note that are inside the MIDI audio, we can always change it. If you want to change the pitch, you can easily change it. If you want to change the composition, change from A to B, you can easily change that, okay? Now, these are the difference between digital audio and MIDI audio. Alright, digital audio is the actual representation of a sound stored in the form of samples. Like I said, digital audio are recordings. We record our audio. So when we record audio, the audio that we record will be in terms of sound wave. When we have a sound wave, at each time intervals, we are taking samples. Right? So whereas a MIDI audio, it is not a digitized sound. We are not recording it in terms of the sound that we hear. We're recording it in terms of commands of musical action. Let's say you want to do happy birthday. How do we create a happy birthday sound? By pressing this button, then that button, and so on. Okay? So a digital audio is device independent. Okay? This means that no matter where you play your sound, let's say I play it inside my laptop, and I play it inside my phone, and I play it inside whatever device, all the sound that is played in every device will be the same, okay? Whereas a MIDI audio is device dependent. It will depend on the playback device. If I have this MIDI file and I play it on my computer, okay, the sound will be different than if I play it on a different device, on a different computer, or a different keyboard, or different instruments, okay? So depending on the playback device, the sound produced will be different. Although the command is the same, okay, what we press is the same, the sound that is produced could be different, all right? A digital audio will have a bigger file size because it requires a larger storage space, okay? Since we are recording, when we record things, it will take samples, right, at each second, so there will be more data stored, okay? More bits stored, so higher storage space. But although it has a higher storage space, the playback quality is always consistent, okay? It will sound the same every single time we play it, all right? Whereas a MIDI audio will have a smaller file size because what we're recording is just the things that we press, okay? So we have a MIDI audio, okay? We can play it a lot faster, a lot quicker, okay? Because there are less file size, okay? But the playback quality is less reliable, okay? Because depending on our device, the sound could be different. Alright, a digital audio is editable but not completely. Okay, when we have any audio that we record, of course we can edit it. We can trim it, we can splice it, we can assembly, we can change the pitch, we can do whatever, but it is not entirely editable. Okay, for example, if I record a word that says I love you, okay, then the sound that is recorded will have a certain sound wave, right? So when I play it, it sounds I love you. But if I want to change the audio and say I hate you instead, the word love and the word hate sounds completely different, and you can't edit that. Okay, you need to somehow re-record it, re-digitize it. Okay, whereas a MIDI audio, everything is completely editable. Let's say I write the song Happy Birthday and I play the song on my piano, okay, on my digital keyboard piano, okay, and then suddenly I want to make my own rendition, okay. I can just move the notes around in my editing software, so every single thing is editable. Okay, I can just change the composition really easily. Okay, even I could change the whole entire song if I want. Okay, so without actually degrading the audio quality, I can always change whatever things that are inside the MIDI audio. Okay, digital audio can easily be used for spoken dialogue, of course, because we can easily record what we hear. Okay, just click record, so wherever things that we speak, we can record it. Okay, whereas MIDI audio, since it is performance data, the things that we press, okay, as musical notes, it is not suitable for us to use it as a spoken dialogue. All right, digital audio does not require knowledge of music theory. Why? Because all you do is just you press the recording button. So if you have a friend that can play the piano, let them play the piano. You can just click on the record button to get that audio file. Whereas if you want to do a MIDI audio, you need to have someone that can actually play it and record what they press. Okay, so that is the difference between digital audio and MIDI audio. Alright, so let's move on to system sounds. System sounds are used for various system events on your computer. Meaning that sometimes when we have certain events on our computer, let's say you click on something wrong and you hear ting, 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 right? That is a system sound. Those are actually sounds that are produced due to certain events that happens on your computer. Okay, so these sounds are already built inside your computer. Okay, for example, sound during computer setup. Okay, when you open up your computer, there might be certain sound that is produced. Okay, warnings, the beeps. Okay, those system sounds are already inside your computer, which you can always access if you want to change it. Alright, so in Windows, it is stored as .wav files, and in Macintosh, it is stored as .aiff files. Right? Okay, then we have sound file formats. Okay, there are different file formats of sounds that we can have. Okay, in Windows, you can digitize your sound as WAV. Okay, since our system sounds are stored as WAV. Okay, Macintosh, you have AIF or AIFC. Okay, but the most commonly used sound file is .mp3. Why? What is that commonly used file format? Because within an MP3 file, there is a compression algorithm to help save space. Meaning that if you compare a recording that is recorded in WAV and recording that is recorded in .mp3, MP3 will have a less file size but with the same quality as WAV. Okay, very good quality but less file size with MP3. That is why people like to use MP3. Okay, but if you have audio and also video together, it is known as MP4. Okay, MP3 can't contain video file. Okay, MP4 can contain both video and also audio within that one file, right? Alright, moving on. So whenever you want to insert sounds inside your multimedia project, there are certain things that you sort of need to think about, okay? You need to determine the file formats that are compatible with your multimedia authoring software and the delivery medium you will be using. So depending on the software that you want to use, certain software will have certain file formats that it can be played. There are certain file formats that cannot be played. So depending on the software that you want to use, make sure that your file formats can be used on that particular software. Alright. Next thing, study the sound playback capabilities offered by the end user system. So let's say your device, okay, cannot play a larger a sound that have a larger file size. Then you might need to downsampling your file size, or you might need to I don't know, edit your sound a little bit so that you can lessen the quality. You know, you need to sort of keep in mind of where you want to play your sound so that you can cater to that device, right? Next thing, decide what kind of sound is needed and where these audio events will occur. So if you want to place your sound inside your video project or something, okay, keep in mind of, you know, what kind of sound you want to do. Let's say inside my video project, I want to put a background music. So what kind of background music? A happy music? A sad music? Okay, and where this audio events will occur. So maybe you want to put it at the front of your video or at the back of your video, or while people are singing. Okay, you want to put that sound there. Okay, so you can actually include this inside your storyboard and plan out where you want to place your audio, right? Also, you can decide when and where you want to use either digital or MIDI audio. Maybe in your project, there are certain parts you want to put digital audio, there are certain parts that you want to put MIDI audio. So it's all up to you. Okay. The next point is acquire the source material either by creating it from scratch or purchasing it. Like I said, whatever source materials that you use, you can either create it yourself by recording your own sound, or you can purchase the sound. Maybe you want to put Taylor Swift's song inside your audio, inside your video. Maybe you can purchase the song first before you can put it inside there. But keep in mind of the copyright issue. Okay. So once you have placed your audio inside your project, you can always edit the sounds using trimming, using normalization, using whatever techniques that I have previously mentioned before. Okay. So lastly, you need to test your sounds to be sure that they are timed properly with your project. Okay. Once you place your sound, let's say you put sound effects. Okay. You need to make sure that the sound effects you place inside your project are timed properly so that it is not out of place. Okay. Let's say you have people clapping, the video of people clapping. So in order to make that sound more dynamic, you can place more sound of people clapping, but you need to make sure that the sound plays exactly at the time frame that you put in. Okay. Alright, keeping track of your sound. So when you have an audio CD, okay, although right now we hardly use CDs for your audios, right? Okay, we just use MP3s inside our phones, inside our devices. But previously, okay, when we have CDs that we buy from companies, okay, they will use a Red Book audio standard, whereby the standard has the sample size and the sample rate of 16 and 44.1 kilohertz separate, respectively. Okay, this standard is used because this is the standard that allows the human ear to hear the sound properly. Okay, it creates an accurate reproduction of sounds. All right. Okay, next we have the sounds for mobile. Okay, usually when we have mobile phones, the sounds that we associate it with are ringtones. Okay, when we have ringtones, we can either create it using an internal MIDI software, or we can just play it from a stored sound file. Okay, let's say you want to do a ringtone. Okay, one way is for you to create it yourself by using a MIDI software like GarageBand, or I don't know if you know this like old Nokia phone, you know, the blue, you know, when you throw it at people, like people could die from that phone, you know, the old Nokia phone. So the old Nokia phone, you can create your own ringtones there as well by pressing on buttons. So number 2 3 times, number 5 2 times, number 7 8 times, and those buttons will create different sounds. Okay, that is using a MIDI software. So with our phone nowadays, we have things like GarageBand, you have different software that we can use to create our own ringtones by creating a MIDI file. Okay, or we can just use any sound file that we store inside our phone as ringtones. All right. Next we have is sounds for the internet. Okay, I think this is the last part. Okay, sounds for the internet. When sound is included in a web page, it is actually not part of the web page. All right, it is a separate file which is then embedded in the web page. This means that whenever you have a web page or a website, okay, the sounds that you hear, let's say you have a play button of your sound, okay, and you click on that play button inside your website, okay, the website doesn't actually, what's it called? It is not part of the website, okay? The website did not produce the sound. What the website does is it embeds the sound into the website, meaning that the sound is actually in a different place. It is not inside that web page. Get me? Okay? All the sound are stored inside a database. So if you want to use that sound inside your project, it will actually link from that storage, it will link that sound to that file. You get what I mean? So let's say if you click on the play button, it will play the sound that is stored inside that database. Okay, this is called embedding. All right. So if you want to embed the sound into your web page, you can use HTML, which is hypertext markup language. This is a language used to write web pages or websites. Okay, for example, if you see here, ehref equals to mysound.wav. Mysound.wav is the file, is the sound file that you want to play. So if you click on that link, you can play that sound because that sound is embedded into that web page. All right. So on the internet, media players will play audio files as soon as enough data has been temporarily stored in your computer's buffer. So on the internet, whatever sound that you play, okay, it uses a technique called streaming. Technically, streaming is actually a process of playing a sound on the internet while part of the file is still downloading. There is a difference between download and stream. Okay, if you download, okay, and you click on the download button, what it does, it will take that file and it will store the file inside your local storage, meaning that inside your laptop storage or your computer storage, your phone storage. So even if you're offline, you can still play the sound. Okay, but when you stream, let's say you use YouTube or you use Spotify, if you don't have internet, you cannot play that sound. Why? Because how it works is that when you click on the play button, what it does, it will temporarily download the file as you play it. Okay, but if you have a slow internet speed, okay, you will notice that your video will keep on getting stuck, or your audio will keep on getting stuck, because as you play the video or audio, it will be downloaded right as you play it. But if your internet is slow, okay, when you want to play it very fast and the file still hasn't been downloaded temporarily, okay, it can't be played. That's why you have buffering. All right, so only do streaming if your internet connection is fast or you have a lot of internet connection. I mean, you have a lot of data for your internet. Okay, but if you, just a tip, okay, if you want to hear a certain song, if you play a certain song multiple times in a day, it is best that you download it so that you can store it inside your local storage, so you can play it all the time without using your internet data. But if you do streaming, okay, if you play it 10 times, you will use 10 times the amount of data in order to play that audio. Every single time you play it, you will use data. Every single time you play it, you will use data. So if you think that a certain audio, you play it play it in a lot amount of times, okay, what am I talking about? Okay, if you play a certain songs a large amount of times, then it is best that you download it so that you can, of course, play it offline and you don't have to download it every single time you play it, because that's how streaming works. Okay, it will download your audio file in a temporary storage, which is known as buffer. So when you close it, the buffer will be removed. Okay, so when you want to play the audio back again, it will be downloaded again. All right, so that's how streaming works. Okay, and I think, yep, that is the end of this chapter. Okay, see you in our next video. Bye.